ladies and gentlemen. So we're back at my house, and before I begin the lesson for today, I just wanted to show you my birthday rose bush. I'm very excited because you can see that it is blooming. Isn't that beautiful? Hasn't bloomed in a long time. So I'm very proud of my birthday rose bush. I take very good care of it. It's right here on the table. All right, so today what we're talking about is, we're still talking about volume, and I have a little project I'm going to have you kind of help me out with a little bit here. We're going to use it actually as an example. So I have a little horse. It's a ceramic horse, and let's see if you're real close. And I'm going to send this to my niece. All right, shout out to all of you. Abby, I know loves horses, and the rest of you that love horses. And so to send this to her, I'm going to put it in this box. Okay, so I'm going to put it in the box. Alright, now the problem is I don't want it to bounce around in there, so there's extra space. So I'm going to fill the box. I have these packing peanuts. So I'm going to fill the rest of this box with the packing peanuts. So, I don't know how many it's going to take there. Alright, I'll cover it all. Okay, so then I'm going to move around and it'll be safe. Okay, so I filled it with the rest of the packing peanuts. Now, this would be fine. I could send it to her like this, but you'll notice that it's kind of a Christmas box, and it's for her birthday. So I kind of want to wrap it with something that's a little less Christmassy. So I have some wrapping paper here. So I am going to wrap this box. Right. So I wrapped those sides. Okay. And now I'm going to wrap these sides so that it's all wrapped up. That's very well. Okay. Not the best wrapping job, but you get the picture. All right. And now my present is all ready to go. Okay. All right. Ta-da! So the question is, in this project, what part of the project had to do with volume? So think about that, and let's take a look. So the part that had to do with volume was when we had to fill the box. And if we are filling the box, we know that we're going to have to find the volume. Volume means to fill. Okay, the amount of space it takes to fill the box. So in order to find the volume of this box, we need to know the height, which is 4 centimeters, and the width, which is 3.5 centimeters, and the length, which is 3 centimeters. So we use our formula, volume equals area of base times height, and we know in this case that's simply 4 times 3.5 times 3. Okay, so when we multiply those, we're going to have 42 centimeters cubed is what it's going to take to fill this with packing peanuts. All right, so volume, how much it takes to fill. Now, what part of the project had to do with surface area? Well, the surface area of the box has to do with how much it takes to cover the box. So in this case, we are looking at surface area right here. I need to get a new stylus, as you can see. Okay, surface area. So to find the surface area, we haven't done that in a little while, but we still need to know the length, which we said was 3 centimeters. And the width, which is still 3.5 centimeters, and the length, which is 3 centimeters. Now, if you recall, in order to find the surface area, what we did was we found the net. And the net, remember, and if you recall from the video, I kind of showed you the wrapping paper looked like a net, kind of. All right, so it looks something like this. And then in order to find the surface area, we're going to be looking at, let's see. Oh, you know what? I made a mistake here because this is the height is not 3. Whoops. The height is not 3. The height is 4. Excuse me. Okay, so we have the one measurement here would be 4, and remember all of these then are 4. This one's 4, this one's 4, this one's 4, this one's 4. So if that's the height, then this one can be 3.5 right here, this one right here. And if that's 3.5, then the area of this part of the figure is 4 times 3.5, which would be 14. Now remember, if that's 14, then the side opposite, the opposite face would also be 14. All right, then if this is 3.5, then this is also 3.5, and this would be 3. That means that 3.5 times 3 would give me an area for this face of 10.5. And of course, if that's 10.5, then this one is 10.5. Okay, and then finally, if this is 4 and this is 3, which we can see, then that means that this area is 12, and of course the face opposite from it is 12. Now if you recall, that means we're going to add 14 plus 14 plus 12 plus 12 plus 10.5 plus 10.5, and that's going to equal 45 centimeters squared. Now, if you recall, we did have a formula we could use for the surface area of a rectangular prism. And it makes sense from this diagram, from the net, if you recall, because it's 2 length times width plus 2 length times height plus 2 height times width. So you could use that also. All right, now, what if instead of a box, I had a gift for my niece that was this shape? Now you'll notice it has little decorative flowers on it. That's kind of what it's going to have on the outside of it once it's wrapped. So if the box looked like this, now what I want to know is what would it take, or how would we find out how much it would take to fill this box? Now this time it's a cylinder. So let's recall that in order to fill the box, we're going to need to find the volume. And the volume of a cylinder, area of base times height, is pi r squared h. Now, this cylinder should look a little familiar because in your work this week, you've already found the volume of this cylinder. All right, so what you should have found was 3.14 times 6 squared times 11 is actually 1,243.44 inches cubed. So you've actually already found that. All right. So in order to fill this box, it would take a little bit more packing peanuts. The next question is, what would it take, or how much would it take to wrap this box? How would we find out how much it takes to wrap the box? All right, if you recall, this time when you are wrapping a box, okay, if you recall, we are talking about wrapping, which would be surface area. Now it's been a little while since we've talked about the surface area of a cylinder, but you've all done it. If you recall, if we unwrap this box, it's going to look something like this, right? And that means that we have to find the area of each of these pieces, this circle and this circle, for example. But we know that the area is pi r squared, so pi r squared would be for this circle, and pi r squared for this circle. So in this case, that would mean 3.14 times 6 squared, which is about 113.04, but I'm just going to round it to 113. And the same would be true for this circle up here. All right, so I have 113 up here, and I have 113 on here. Now, if you remember, what about this rectangle? Well, the rectangle, remember, we're going to use 2 pi r, which is the circumference. That's how far long this is right here, times the height. So in this case, 2 pi rh is going to give us 2 times 3.14 times 6 times 11. If I don't really have room to write all of those things down, but if we were to multiply all of that out, we would get 414.48. Now, if you recall, we can add all those together. And 113 plus 113, that's our two circles, plus 414, 0.48 is going to give us a total of, it's going to give us I didn't want to do that, did I? It's going to give us a total of 640.48, 640.48, and that would be, what are we, inches squared. Now, remember, there is a formula for surface area that you could use. Okay, the formula for surface area of a cylinder is actually 2 pi rh, that's the rectangle in the center. That's the rectangle here in the center, and then 2 pi r squared are the two circles. So if you'd like to, you can always use that formula. All right, so we've pulled together a lot of things that we've been working on the last few, even the last month, actually. Now, what I'd like you to do next is I would like you to take a look at these two problems. Now, these two problems, read them carefully. And the first question is, which of these two problems is going to require you to find the surface area? So the surface area, remember, means we're going to wrap or cover. So in this example, the wrap or cover would have to be letter B. To wrap or cover is going to be letter B, because we are talking about covering a couch cushion. Now remember, to do that, we would use, in this case, since it's rectangular, we would use the 2 length width plus 2 width height plus 2 width length, or height width, height length. Okay, now, how do I know, A is the only one left, how do I know that that's volume? So if that's volume, it's because we are filling the pillow with foam. All right, and we know the formula for that is area of base times height. And in this case, it's a triangular prism, so you'd have to find the area of the triangle times the height. We're not going to do that. So here's what comes next. What's next is there are 4 problems on Seesaw. Okay, you're going to have to decide whether you need the volume or the surface area. I've put the 2 formulas, or 4, I guess you could look at. The formulas here, you can take a screenshot of this, jot them down, make sure you've got your formulas. You can always look them up also. And then finally, I want to remind you that we do have an assessment tomorrow. Please don't be too nervous about it. It's going to be about volume. Yes, there'll probably be a surface area problem on there, maybe a couple review problems. It's not going to be nearly as long as a regular assessment, at least I don't think it is. It's going to be on Google Forms, all right? And you will be able to do corrections. All right, go to Seesaw and work on your homework.